All right, this is lesson 2 of unit 2. We're going to talk about properties of parallel lines. First thing that we need to talk about is that if you have these arrows drawn in a line segment, that tells us that they are parallel. So in this case, we know that AB, that segment, is parallel to CD. This is another symbol for parallel, those two lines drawn next to each other. Segment EF, that's considered a transversal, which just means that it intersects your two parallel lines. Interior angles are any angles that are inside of our parallel lines. So in this case, all these angles C, D, E, and F, those are all considered interior angles. So interior angles are inside our parallel lines. Exterior angles then would be outside the parallel lines. So we would have angles A and B and also G and H. Those are all your exterior angles. Alternate interior angles means that they're on the inside, but they're on opposite sides of our transversal. So C and F are a pair of alternate interior angles. And then we also know that E and D are another pair of alternate interior angles. These angles are always equal in measure. So that means that C and F are the same degree measure and E and D are the same degree measure. Alternate exterior angles are angles that are outside our parallel lines but on opposite sides. So we have angle A and angle H, and then we also have angle G and angle B, and they are again equal in measure, meaning angle B and G are congruent or equal, and angle A and H are equal. Corresponding angles are angles that are in the same location on our intersection. So for this one, I'm just going to use colors and box it in for you. So angle A and angle E, those are corresponding. They're in the same location in your intersection. So here's one intersection, there's another one. They're on the same spots. We also have angle B and angle F. Those would be corresponding angles. They are equal. Another one would be angle C and angle G. Those are corresponding. And then the last ones that we have would be D and H. Okay, and again, these corresponding angles are equal in measure, meaning A and E are equal, B and F are equal, etc. Same side interior angles mean that they are on the same side of the transversal but inside. So we have angle C and angle E, and then we have D and F. These ones are supplementary, which if you remember from the previous lesson, means that they add up to 180 degrees. And you can see that angle C is obtuse and angle E is acute. So it would make sense that they would add up to 180 degrees. D is acute, F is obtuse, again, would make sense. All right, we're going to look at an example at the bottom here. So we're given that if line M is parallel to line N, so we can mark those as parallel, and measure of angle 1 is 150 degrees, we want to find the measure of the remaining angles and provide your reasoning. So if you look at the measure of angle 2, we know from our previous lesson that we have a straight line. So we know a straight line is 180 degrees. To find angle 2, we're going to do 180 minus 150, which is just 30 degrees. Our reason then is angles on a line. We can label that in our picture. Measure of angle 3 then is a vertical angle to angle 2. So I know that it also has to be 30 degrees. Vertical angle. Your reasoning might differ than mine if you went ahead and looked at it first. You could have also said angles on a line to angle 1. It just really depends on what you were thinking for your reasoning for these. There's several different ways you can think about it. So angle 4, I'm going to say, okay, I know that it's vertical to angle 1. So angle 4 also has to be 150 degrees. And I'm going to say vertical angle to angle 1. All right, to find angle 5 then, I know that we are given angle 1 is 150. So then angle 5 is a corresponding angle to angle 1. So angle 5 is also 150 degrees, and that's because it's a corresponding angle. Angle 6 is corresponding to angle 2, so that has to be 30 degrees, 150 there, or it could be alternate interior. So 30 degrees, I'm going to say alternate interior to angle 3. Angle 7 then has to be 30 degrees. And it's vertical angle to angle 6, or whatever your reasoning was here, angle to angle 6. And then I know that angle 8, that measure has to be 150 degrees, and it's vertical to angle 5. Okay, vertical to angle 5. All right, we are gonna do 2 quick examples here to solve for x. If you notice the angles that are labeled, these are alternate interior angles. And we know that alternate interior angles are equal. So we're just going to set these 2 angles equal to each other and then solve for x. So you're going to subtract your 3x, 2x minus 25 equals 25, 2x equals 50, and divide by 2. We know that x is 25. Okay, and then that would be your answer for that. If it asks for reasoning, your reasoning in this case is that they are alternate interior angles. For example 2, when we want to solve for x, we know that this angle and this angle are supplementary. So that means that they add up to 180 degrees. So we're going to do 4x plus 5 plus 2x minus 11 equals 180, and then solve for x from there. When you combine like terms, then 4x and 2x, we have 6x, 5 and negative 11, we have negative 6 equals 180. Add your 6, and then divide by 6, and you get that x is 31. Always double check what you're being asked to solve. We were just asked to solve for x, so we have our answer. X is 31. Our reasoning is because those 2 angles are supplementary.